So what kind of shape does this equation, z equals 6, what kind of shape does that make in the xyz space?
It's a plane.
Yeah, it should be just a flat horizontal plane up at z equals 6. Kind of like if you took a copy of the xy plane and then just boosted it up 6 units in the z direction. So and what I want to do is I want to convert this to spherical coordinates. And so that means I want to have potentially formulas for rho and theta and phi that also describe the exact same horizontal plane, just in terms of these. So I'm going to try to remember for a moment what these formulas were. So rho is the square root of x squared plus y squared plus z squared. Tangent of theta was y over x. And then phi was, yeah, I think you're right. I think it was arc cosine of, was it z over rho? Yeah, because cosine of phi would be adjacent over hypotenuse, that would be z over rho. Yeah. Okay, so pretty confident that these are right. And let me think about this. So if I'm trying to do a flat plane, then theta, which is the angle from the positive x-axis, should be allowed to be any value at all from 0 to 2 pi, because you've got to generate this plane in every direction. So I think theta might be a free variable. Phi, which is the angle from the z-axis, is going to be a function of, well, I should say that rho is going to be a function of phi. Right? Because as you're staring directly up at the z-axis, rho would need to be 6, right? But as phi gets larger, as phi goes from 0 up to pi halves, rho is getting larger too, because your plane, your flat horizontal plane, is getting farther away from the origin as phi increases, as the angle phi increases. If that's not super obvious, let me try to draw what I'm talking about. Here's z. Here's my xy plane. Here is the plane z equals 6. And so this distance is rho, and this angle is phi. So as phi, that angle becomes larger, then rho also has to become larger, because that's the distance from the origin to the plane. Phi can be anywhere from 0 up to pi halves, right? It wouldn't make sense to have a phi that's larger than pi halves, because larger than pi halves means you'd be pointing down into the and below the xy plane. So rho is a function of phi. What is the function that gives me this rho as phi? So if I think of this as a right triangle here, this side length is 6. And to get rho, I would need to use the arc cosine. No. the cosine. Sorry, maybe I'm confusing myself. In order to not confuse myself, I'm just going to start from this equation right here that says phi is equal to arc cosine of z over rho. And then I'm going to rearrange it until I have rho. So that means cosine of phi is equal to z over rho. And that means that rho cosine phi is equal to z. And that means that rho is equal to z divided by cosine of phi. Okay. So, theta is a free variable. Phi just has to be between 0 and pi over 2. And then rho is equal to z over cosine of phi. But remember, for my plane, z is always six. Yeah, this is what we were starting with, that we wanted to convert into spherical coordinates, with z equals 6. And so what I'm going to do is write rho equals 6 divided by cosine of phi. And this is how I find, or this is how I describe that plane using spherical coordinates. Whenever I said that theta is a free variable, what I mean by that is in this plane, theta has to take on all of the values between 0 and 2 pi. Because the plane stretches out in every direction. What we started with over here when I said z is equal to 6, this starting point, since I just said z is equal to 6 and I didn't mention x and I didn't mention y, this implies that both x and y are free variables, right? So if you just don't mention x and you just don't mention y, what you're saying is you're allowing x and y to take on any value. And so as an answer to this problem, you could just say, okay, you know, you don't even have to mention theta is what I'm trying to say. If you just wrote these two, that would be fine as well. You don't have to actually say that theta is a free variable, because just the fact of not mentioning it implies that it's a free variable. Okay. Do another example here. You pick one out. If I want to do theta equals 3 pi over 4. And this is obviously, well, it's not obvious. It could be in spherical coordinates, it might be in cylindrical coordinates, because both of those coordinate systems have a theta. But theta means the same thing in either coordinate system. So we are going to convert to rectangular. What kind of shape does that equation describe in the plane? Yeah, so you can either think of this as being like a half plane, or you can think of it as being like a full plane, depending on what you allow your values of r to be, right? And so, how do I say this?
So it's always about the positive x-axis, right?
Mm-hmm. If this were like cylindrical coordinates, and I say that r is allowed to be any real number, like including negative numbers, then this would be a plane in space. because that means your r direction could be positive or it could be negative. And so as you're looking at the angle 3 pi over 4 away from your x-axis, you can create all of these different values, any value of z, any value of r in front of you or behind you. But let's say this was like spherical coordinates, and we say that r has to be positive, right? Then this would be describing a half plane. But I'm not really going to be super nitpicky on your exams or anything like that. If this were a question on an exam, I'm not going to take off points whether you consider this a plane or a half plane, because it's just not super clear. Let's go ahead and just pretend this is a plane to make our lives easier. And we want to convert this to rectangular coordinates. So let me first think about a little xy plane here. Because we can tell here that z is a free variable, so it's allowed to be anything. So what matters is how this looks in my xy plane. You can think of this as the trace of this in my xy plane here. The angle 3 pi over 4 away from the x-axis would look like this. Right, and so if this were a half plane, maybe the trace would look like that. And if it were a full plane, then you could say, okay, I'm allowing r to take on negative values, and it could look like that. So anyway, give me an equation that makes y a function of x, right? Give me some y as a function of x. Anybody? Perfect. Yeah. So if I just say y is equal to negative x, writing y equals negative x implies that z is a free variable and z can take on whatever values it wants. And so that means this equation is describing the same plane in 3D space as that equation. Whenever I write theta is equal to 3 pi over 4, that's either telling you that r is free and z is free, or it's kind of like the same thing as telling you that rho is free and phi is a free variable. And whenever you write y equals negative x, that's just implying that z is a free variable. So we're talking about the same plane. Does that make sense to everybody?
If you put like x is r cosine the angle, then y r sine, and you put the ratio, we're going to find y is x.
Yeah. Okay. Let's do another one. In this case, I want to convert from rectangular to spherical. And what I'm given is x squared plus y squared minus 3z squared equals 0. Okay. So again, I'm trying to convert to spherical. I'm going to just remind myself of what those equations were. So rho is equal to x squared plus y squared plus z squared. Theta, tangent theta is equal to y over x. And phi was arc cosine of z over rho. So we're trying to get this equation, which is in terms of x, y, and z. We want to just completely convert it to an equation that only mentions rho, theta, and phi. One thing I might do to start is say rho squared would just be x squared plus y squared plus z squared. That might be helpful if I write something like x squared plus y squared plus z squared minus 4z squared equals 0. Because then this whole mess just becomes a rho squared minus 4z squared equals 0. And now I have this z left to get rid of, and I have an equation over here that includes rho and phi, which I'm allowed to use, those are spherical coordinates, and a z. So let me just rearrange this equation to solve for z. And I would get cosine of phi is equal to z over rho. So that means z is equal to rho cosine phi. And plug that over here, and I end up with rho squared minus rho squared cosine squared phi. Oh, I forgot a 4. Minus 4 rho squared cosine squared phi equals 0. I could factor out a rho squared and get rho squared times 1 minus 4 cosine squared phi equals 0. I guess you can't really simplify that. Anyways, this equation should give you the same surface, should be describing the same set of points in space as my original equation right here. But this original equation was telling you, hey, this set of points, the surface in space, is described by x, y, and z, and then my new equation is telling me that you can describe that with just rho and phi. Let's see if it works. I'll try my best to do this quickly. So I'll go to GeoGebra and make it do the only thing it's good at. Come on. .3D. And try to type these in really fast. X squared plus y squared minus 3z minus 3z squared equals 0. The only way that the left side of this equation could be equal to 0 is if rho is 0, which is boring. That's just the origin, if rho is 0. Or phi is such an angle so that cosine squared is 1/4. So that means phi, the angle has to be fixed.
Yeah, 5/4.
Yeah. So phi is some constant, which means the angle away from the z-axis has to be constant. And then in that case, if this expression in parentheses is 0, then rho is free to be whatever it wants. And so imagine the phi, the angle from the z-axis, is constant. Rho is whatever it wants. It's a free variable. That would give you a cone. And so just logically, that seems to make sense that you would get the surface of a cone.